The topic is relating scale drawings to ratios and proportionality. The essential question is, how can I solve problems involving scale drawings of figures? So, for starters, in the notes, we're going to write down the definition of a scale drawing. And a scale drawing is a reduced or enlarged proportional, it's got to be proportional to be a scale drawing, two-dimensional drawing of a two-dimensional figure. And since it says it's a reduced or enlarged proportional two-dimensional drawing of a two-dimensional figure, there is a word that represents when it's smaller than the original, and that's called a reduction. And that's when the links in the scale drawing are smaller than those in the original. So I'm going to go ahead and just draw a quick little sketch of what that could possibly look like. And you're going to imagine that this is one of those equilateral triangles, okay? I know my drawing is kind of not to scale, but you're going to pretend that all these sides of this triangle are 5 units in length. And this point right here, this vertex, I'm going to label it as A. This vertex right here, I'm going to label it as B. This vertex is C. And this is going to be the original. Okay, the original triangle. And if I want a reduction, then the reduction is just going to be a smaller version of this original. But keep in mind, for this scale drawing, that's a reduction. It needs to be proportional to this original drawing, okay? So I'm going to make it a reduction happen. And I'm going to say that the scale factor is 1/2. So the scale drawing is going to be half the size of the original. And I apologize for my drawing ahead of time because I don't imagine it being perfect. Alright, so if this was the original and the scale factor was 1/2, half of 5 units is 2.5 units. Okay, and we're going to label the new vertexes to correspond to the original. So this right here is A, this right here would be A prime, and this one would be C prime, and this vertex right here is B prime. And this right here is a scale drawing. The scale drawing is a reduction of this original. This original and the scale drawing are similar to one another because we have proportional sides, it's the same shape, and it would have the exact same angle measures since they're both equilateral triangles. This angle would be 60 degrees, 60 degrees, 60 degrees. This one would be 60 degrees, 60 degrees, 60 degrees. I hope you know that in every single triangle, if you add up all the interior angles, it will equal 180. So if it's an equilateral triangle, I know that all of the angle measures inside that triangle will be equivalent to one another, like 60, 60, 60. 60, 60, 60. So that's a reduction, okay? This is a scale drawing of the original. The other part of scale drawings are when they get bigger, so an enlargement would occur. And the word that means enlargement is enlargement. So it gets bigger. Or I've also seen it called a magnification. Okay? And an enlargement and a magnification, that's when the links in the scale drawing are larger than those in the original. So now let's pretend my original, I'm just going to copy this one. Let's pretend that one's the original and try my best to imitate it. Okay, again, assume it's an equilateral triangle. I'm just telling you right now. And this is going to be vertex A, B, and vertex C. And this is going to be the original drawing. And it's going to be an equilateral triangle, so I'm going to tell you that This side right here is 2.5 units in length. And what I want to occur is I want an enlargement. So we're going to make an enlargement happen. Okay, just to make it easy, I'm going to make the scale factor be 2. The scale factor is 2, okay? So that means that your scale drawing is going to be double the size of the original. And again, I apologize for my drawing ahead of time. Pretend it's double the size because it's probably not going to appear that way. Luckily, I'm going to label everything, so that will hopefully spare my drawing a little. Okay, so this A vertex corresponds to this point right here, and we're going to call it A prime. And then this would be B prime. And this point right here would be C prime. And since we know that the side lengths in the original are 2.5 units, all three of them, and I'm telling you the scale factor is going to be 2, I'm just going to go 2.5 times 2, which is 5 units. Okay, that's my scale drawing. Okay, so the two types of scale drawings that can occur are reductions, when it goes from big to small, or enlargements, or you can also say magnifications, when it goes from small to big, okay? And you should know that this triangle is similar to this triangle because we have proportional sides, they're the same shape, and they're going to have the same exact angle measures. Those are the 3 criteria for figures to be similar, okay? And remember that the symbol that means similar looks like this. Okay, that's a symbol that means similar. Okay, and scale drawings are similar to the original. Because they have to be the same shape or figure. They have to have equivalent angle measures. That means they're equal. And 3, they need to have proportional sides to the original. If they don't meet all 3 of the criteria, you can't call them similar. Okay, so the next part in the notes says that original and scale drawings have blank. And what I want you to write right there is 1-to-1 correspondence. And I'll explain what that means in just a second after you write down that big old word. 1-to-1 correspondence. Okay? So original and scale drawings, they have 1-to-1 correspondence. This means that each point in one figure corresponds to one and only one point in the other figure. So this one corresponds to this one. See how it's labeled? A and A prime. This one corresponds to this one. It's labeled C and C prime, and so on and so forth. They might try to trick you by maybe flipping the second image upside down, but you need to be able to kind of modify your outlook and match the segments to each other and the vertexes to one another because of the 1-to-1 correspondence that happens, okay? All right, so right down here for your summary, you'll notice that we label the original with typically A, B, and C, or whatever variables that they want to use. How would you label a point in the original, A? How would you label its scale drawing, okay? What do you do to that A to make it be represented within the scale drawing? Go ahead and do that. So in this first example, you'll see that it's asking for the scale factor. So I have the original image right here, and I have the scale drawing. Since it's labeled scale drawing, then I know for sure that these two images are similar to one another. and they're asking for the scale factor. So since I've taught you that scale factor is just like finding the unit rate, because they're the same thing, but they use the word scale factor just when you're dealing with geometry, I want you to go ahead and create a table, okay? So in the X column, I want you to write the word original to represent this figure right here. And then in the Y column, you will write scale drawing. Okay, so remember how I talked about the one-to-one correspondence that occurs between an original and a scale drawing. So in the original, this side length is 1 centimeter. And I highlighted it pink. If you have any colors, then you might want to do that as well. But anyway, this side length is 1 centimeter. So in the original, I'm going to label that right there. And in the scale drawing, the side length E prime, H prime, that corresponds to that 1 centimeter is 1.5 centimeters. So I'm going to write that in the scale drawing part. Okay? And since I have other values represented within the figures, I'm going to go ahead and put them also in there. So 2 centimeters corresponds to that 3 centimeter side length in the scale. All right? I'm going to also highlight that so that you see, okay, this one's there, that one's there, that's the first one. And then that other part, the 2 and the 3, I'm going to just highlight that just for, hopefully it helps you understand things a little better if we use some colors to help you represent things. Okay, so now we need to find the scale factor, also known as the unit rate. Put that in parentheses right there to remind you, okay? And I hope you remember that you go y divided by x. And you'll see here that we have the y value. It's 1.5 centimeters. And you can pick that one, 1.5 centimeters over 1, or I can go 3 over 2. The reason I can pick any one of those values that correspond to one another is because I already know that it's going to be proportional. I know it's proportional because this says scale drawing. Because remember, scale drawings, they fit this criteria. They're the same shape, they'll have equivalent angle measures to the original, and they'll have proportional sides to the original. So I already know that these sides are proportional. So just to find the scale factor, you should go y divided by x, and I can do 1.5, or 1 5/10, over the x value, which is 1. So right there, that's my unit rate. Similarly, I could have done 3 over 2 if I wanted to. And when I go divide by 2, I would get 1.5 over 1. Okay, so that right there is the scale factor. So you need to know that you multiply the original by the scale factor to get your new side lengths. Okay? And just to show you that, if I went 1 times 1.5, I get 1.5. If I go 2 times 1.5, I will get 3. See? Okay. So we took this x value, we multiplied it by 1.5 each time to get the corresponding y value. Because that right there is a scale factor. Okay. So I want you to kind of take a look right now at this comparison. The scale factor is it greater than 1, less than 1, or equal to 1? Well, the scale factor is greater than 1. And what happens when the scale factor is greater than 1? You have an enlargement. And another word for enlargement is magnification. Okay. All right, the next problem. Let's go ahead and let's see, without even doing the table, if you can kind of determine what the scale factor is. I mean, like if the scale factor is bigger than 1, equal to 1, or smaller than 1. And so it started out big and it got smaller, so therefore your scale factor is going to be smaller than 1 or less than 1. Okay? And when that happens, you should know that a reduction occurs. Okay? So let's go ahead and figure out the scale factor. And I do want you to draw out the table just like we did in the previous example. It might be a good idea to pause the video right now and see if you can do it independently without my help, and then unpausing the video to double check to make sure you got it correct. And I know that these two triangles are similar because this one is labeled scale drawing. It's telling me, hey, that's a scale drawing. So it fits those 3 criteria that we wrote down on the front page. Okay, now let's go ahead and look at the corresponding sides because the one-to-one correspondent. So 3/4 of an inch, you can write, instead of writing 3/4, you should know that its decimal equivalent, 3 divided by 4, is 75 hundredths. You can write either one, same thing, okay? You can keep it 3/4, and then that side length of this triangle corresponds to this side length right here of this triangle. Oh, and then same things, 3/4 and 1/2. Okay, and so just to help you visualize it, we're talking about those right there, and then these ones I'm going to just highlight in pink. All right, let's go ahead and determine the scale factor. And remember, scale factor, you find just like you would the unit rate because there's the same thing. Let's go y divided by x, and y is 1/2. You can do 0.5 if you want because 1 divided by 2 is 0.5. And then the x value is 3/4. Or 0.75, and that looks kind of weird, so I am going to write that. 0.5 over 0.75. Now I'm going to divide by 0.75. Okay, so 0.5 divided by 0.75, and we get this right here, okay? And you can write that. Oops, I kind of ran out of room, sorry. 0.6 repeating as a scale factor, or you should know that 2/3 is the same as 0.6 repeating, because look, 2 divided by 3, same exact thing, okay? So let's go back to right here where I went 1/2 divided by 3/4. I'm going to show you how I can get that fraction right there. I'm write it down here, just kind of a little space. I had 1/2 divided by 3/4, and you gotta go keep, change it, flip it. So when you multiply by a fraction, you just go straight across. 1 times 4 is 4, 2 times 3 is 6, and let's simplify that fraction. So divide by 2, and you get 2/3, okay, which is exactly what we got right there. So we can write that our scale factor is 2/3, or you can write 0.6 repeating, okay? Times 0.6 repeating. And then this one should say times 0.6 repeating, but you'll see that I kind of ran out of room, so it's like carried over right there, okay? So I hope that doesn't confuse anybody. So you see in this example right here, we got a repeating decimal as our scale factor. I want you to know this though. If you get a repeating decimal as your scale factor, you should keep it as a fraction in simplest form. That's just what they prefer with scale factor. They don't really like repeating decimals. I mean, although it's not incorrect, it's just preferred that you keep it as a fraction in simplest form. So for example, if for some reason you got 0.3 repeating, just use 1/3 instead. Okay, they're both equal to each other, but this is more preferred. So in this particular example, we had 0.6 repeating as the scale factor, and what I want you to know is 2/3 is more preferred than 0.6 repeating, simply because they prefer scale factor written as a fraction in simplest form. Okay, number 3, that example, it's a little bit different than number 1 and number 2 because it says the scale factor is 1/2. So I know that the scale factor is 1/2. What will be the side lengths of the scale drawing? So it's telling us this is a scale drawing and the scale factor is 1/2. I can tell that, well, obviously the scale factor is going to be less than 1. And when the scale factor is smaller than 1, then you know that a reduction occurs. Okay, and let's go ahead and set up your table just to be consistent with how I'm teaching you how to do this. This is the original and the scale drawing. Okay, and right here, this is 4 centimeters. And this one right here, oops, let me go ahead and highlight that. Just don't get confused. And then right there is 3 centimeters. And then that, that third side length is called the hypotenuse. That's the word you're going to hear definitely in the 8th grade. So when you have a right triangle like this, or like this side right here is called a leg, this side right here is called a leg, and the one directly across from the 90-degree angle, which is the longest, will always be the longest side, is called the hypotenuse. And you can only call it a hypotenuse if it's a right triangle, okay? So hypotenuse is right there, hypotenuse is right there, because these are both right triangles. Anyhow, so scale factor is 1/2, so we're going to multiply by 1/2, or by 0.5, same thing, 5/10. So when you do that, you get your answer. So when you're multiplying by 1/2, it's the same as dividing by 2, because I have 1 in the numerator. So it'd be really 4 times 1, which is 4, and then divided by 2. 4 divided by 2 is 2. And then half of 3 is 1/2, or 1 5/10. Half of 5 is 2 5/10. So let's go ahead and match the corresponding sides. Oops. Okay, so this one is 2 centimeters. The other leg is 1.5 centimeters. And that hypotenuse is it's 2.5 centimeters. Okay, for your summary, you need to multiply, I want you to write this whole thing down. You need to multiply the original image's lengths by the, fill it in order to know the scale drawing's lengths. Then you know the lengths will be proportional to one another. Example 4 wants us to find the scale factor. So go ahead and compare the actual drawing with the scale drawing. What do you notice? That it started out small and then got larger. So what do you notice about the scale factor? If it's started out small and got larger, you know that the scale factor is greater than 1. Okay? And what's the word called when you have a scale drawing that's larger than the original? What actually happened? An enlargement happened, or you could also say a magnification. Okay, and remember about the one-to-one correspondence with drawings like this. So this side length corresponds to this side length right here. So go ahead and fill in your numbers in the table. And then this side length right here corresponds to this side length right here. So go ahead and fill your values in the table. And I do want you to take a second, pause the video, and try to find the scale factor on your own, okay? That's good practice for you. Okay, so this is what you should have gotten. So this right here is 9 units. This one's 12 units in the scale drawing. In the actual, we got 6 units and then 8 units in the scale drawing. So to find the unit rate, the scale factor, you need to go y divided by x. Okay? And you can pick either one of them. They're both going to work because I know that they are similar to each other because this is a labeled scale drawing. So I know for sure that's the same shape. It's got proportional sides and they'll have the exact same angle measures, okay? So I'm just going to go with this one and this one. So y over x, okay? Let's find that scale factor. So divide by 9, divide by 9. And when I go 12 divided by 9, oops, I get 1.333 repeating. So that's really 1 1/3, okay? Because 0.3 repeating is 1/3. Okay, so since there was a 1 right there, it's 1 1/3. Or you could also turn that mixed number into an improper fraction and get 4/3. Okay, those are all interchangeable. They're all perfect for this. You can write any one of them. And since, like, I don't want to write that whole thing or that, I'm just going to write 4/3. Because it kind of fits in that little spot. Okay? So, our scale factor, you could write any one of those. Let's just write them all. Or you could say this. Oops, that should say or. Sorry, my paper slipped. Gosh, that looks a little bad. I don't want you to think it's 1 1/30. Don't want to confuse anybody. 4/3. Okay, so I like to draw the scale factor right here, times 1.3 repeating, or we could say 1 1/3, or we could say 4/3. Again, it's good to be flexible with your numbering, okay? Because they are, in fact, equal to each other. So for this problem, I want to take a second, and I realize that all 3 of these are equal, but I want you to know that if you get a repeating decimal as your scale factor, you should keep it as a fraction in its simplest form. So for example, if you get 0.3 repeating as your scale factor, it would be the best if you kept it as 1/3, okay? So you see when we got to right here, 12/9, you should simplify that fraction down and get 4/3 as your simplified fraction. Although these are all 3 correct, this is the one that's probably the most preferred for scale factor. I want you to answer this next one. I wrote down what you need to write. I highlighted where you need to fill it in. Okay, so I want you to do that. What do you notice about the scale drawing when the scale factor is greater than 1? Write it in right here, what happens. And then what happens when the scale factor is less than 1? Right here, what happens, okay? Okay, number 6. It's presented to you in a little bit different format than what you're used to, but you do need to have flexibility in how you interpret things, okay, and read things. And don't just shut down if it's not presented to you in the same way that you're used to, okay? You're taught the skills to do this, and your job is to expand those skills and use them because you know them. Okay, so it looks like we've got like a rectangle right here, and there's a grid. Let's see, the x-axis is counting by 1s, the y-axis is also counting by 1s, but I can see that they just left the number out right there in between, but they kept the tick mark, and they did that, or I did that when I wrote this because I just need more room. Okay, so if the drawing is modeled using a scale factor of 1/3, what will be the new coordinate? What will the new coordinates be? So they're saying this drawing right here, they want to model it, and they want it to have a scale factor of 1/3. So the scale factor 1/3 is the scale factor, and that is less than 1. So what's going to happen to your new image when we draw it out? It's going to be a reduction, so you know it's going to get smaller. Okay, see how the scale factor is 1/3 right there? So you know it's going to be a reduction. Okay, so I know I'm going to multiply the original by that scale factor of 1/3 to help you come up with the new lengths, or the new points. Times 1/3, okay? All right, so we got to start off by listing what the original points were, okay? So I see that the original point for H is at 0, 6. Original point for I is at 9, 6. The original point for J is at 9, 0. Oh, I don't have K on there. Oh, it's down there, sorry. And that's K is at 0, 0. Okay, so that represents the original drawing. Okay, and now for the scale drawing, I'm going to go ahead and do that in a different color if I have one. Good. And so I got to multiply all those by 1/3 because that's the scale factor. So 0 times 1/3 is 0. 6 times 1/3 is 2. 9 times 1/3 is 3. 6 times 1/3 is 2. And if you're curious about how I'm getting that kind of quickly, it's because multiplying a number by 1/3 is the exact same as multiplying that same number, is the exact same as dividing that same number by 3. So I'm just basically going like 9 divided by 3 is 3. 6 divided by 3 is 2. 0 divided by 3 is 0. 6 divided by 3 is 2. Okay, so this point right here, 9 times 1/3, or you can go 9 divided by 3, which is the same thing. You'll get 3. 0 times a third is 0. 0 times a third is 0, and 0 times a third is 0. Okay, so those are the new points of the scale drawing, and let's go ahead and plot them. So h prime is at 0, 2, and please label that. Whoops. And I prime is at 3, 2. And j prime is at 3, 0. And k prime is still in the exact same spot. Let's go ahead and connect those vertices. Vertices is plural for vertexes, I guess. Okay, and you'll see how it is a third the size of the original, okay? And in previous times, I've shown you, like, here's how you can check and see if you're correct. Take a straight edge and see how the I and the I prime go right to that, that origin right there. In this case, I can tell that the origin is the center of dilation because they're all going to go to that right there, okay? All right, for your summary. Multiplying a number by 1/3 will give you the same answer as dividing that same number by blank. Multiplying a number by 1/4 is the same as dividing that same number by blank. Fill that in. In example 7, it asks, is the smaller figure a scale drawing of the original figure? So you'll see how the original figure is labeled original, and this next figure, it's not labeled scale drawing because you are to determine if it is a scale drawing of the original. And remember, for it to be a scale drawing, it's got to have proportional sides, it's got to be the same shape, and it's got to have the same exact angle measures as the original, okay? So I know these are rectangles right here, and I have the grid that shows me, okay, these are right angle, right angle, right angle, right angle, right angle. So those are all 90-degree angles, and same with this one right here. And I see that they're the same shape, so I just got to determine, hey, do these have proportional sides? If they do have proportional sides and they fit those three criteria, then I can write, oh, scale drawing, okay? But in my table, since I don't know for sure if it's a scale drawing yet, I'm just going to use the word new, okay, like new drawing. So X for sure is the original. And then Y is going to represent just the new one. Okay, the new figure. Okay? And I can do the colors if you still need that support, but maybe you know how to do this now. So this side right here corresponds to this side. We just have to see if they're proportional, okay? So 4 in the original to 3 in the new. 3 centimeters and 4 centimeters. 4 centimeters and 3 centimeters. Okay, and then the next part, I got, so if this one's 1 centimeter, then this one down here is also 1 centimeter because it's a rectangle. Okay, so I need to go ahead and go y divided by x for each one of these because I don't know if it's a scale drawing. I don't know if they're proportional, okay? So y divided by x for this one right here. To find the scale factor, so it would be 3 over 4, and we're going to divide by 4 to find that scale factor. 3 divided by 4, that's the divide sign, is 75 hundredths, okay? So multiplied by 75 hundredths, or you could say 3/4. 75 hundredths is the same as 3/4, okay? And right here, again, y divided by x. Instead of writing 1/2, I'm going to write 0.5 because I know that's the same exact thing. I can be interchangeable with those because they're equivalent. So it'd be 0.5 over 1. And oh, that's already 1 in the bottom, so that's the scale factor there for that. So you'll see that they're not the same. This is not a proportional relationship. So this is not a scale drawing, okay? Did that make sense? Circle that right there. That's kind of a big deal. So no, the new figure is not a scale drawing of the original. And how come? Because of that. Not the same scale factor, so it's not proportional. And since it's not proportional, it doesn't fit that third criteria to be a scale drawing. Okay. So I cannot label this scale drawing because it's not, simply because of that, okay? It fit the other two criteria, but just not that third one, so therefore this is not similar. These two are not similar to each other. Okay, number 8. If 1 inch on the scale drawing corresponds to 12 feet in the actual apartment, find the actual areas of each room. Okay, so there's a couple points of information that are definitely important. So I'm going to go ahead and highlight them. So 1 inch on the scale drawing corresponds to 12 feet in the actual apartment. Okay, so let's look at this right here. This right here looks, it's a scale drawing. It tells us right there. So I need to know that 1 inch on here, on the scale drawing, is equal to 12 feet in real life, okay? So as I look here, oh, this right here, that's from there to there, that's 1 inch. So in real life, that's 12 feet. So I'm going to just start kind of picking this apart and labeling stuff because we've got to find the area of all this stuff right here. Oh, and real quick, do you remember how to find area? What are the shapes here? Yeah, they're rectangles and squares, it looks like. So area is going to be length times width because they're squares and rectangles. Okay, length times width. Area of squares and rectangles is length times width, okay? All right, let's start labeling here. So I'm going to start with the easy stuff because I know from here to here, that's going to be 12 feet. Okay, because 1 inch on this scale drawing is 12 feet in real life. So that would mean, well, this whole thing right here, the whole thing is 2 inches. So 2 times 12 is 24, so that right there is 24 feet. Okay, what else we got right here? Oh gosh, this is 2.5 inches. So this whole thing, I gotta multiply that by 12. So 2.5 is the same as 2.5 times 12 is 30 feet. In real life, that's 30 feet. So like the outside of this whole entire apartment, it's a 30 foot by 24 foot apartment. And so let's write that down right here. So it's a 30 foot by 24 foot, by apartment. So the actual area is going to be 30 times 24 is 720 feet squared. Okay, and the reason I used feet squared is because I found the area. When you go length times width, you get the area, okay? So that's that, the entire apartment. Now, see a kitchen here. Oh, there's a kitchen. So from there to there, oh, that's 12 feet, so I can label that easily. In real life, it's 12 feet. So, okay, 1/2 inch. So 1/2 times 12, half of 12 is 6. So from here to here, it's 6 feet. Okay, so it's 12 by 6. I should probably label feet, huh? Or you could just label at the end with your answer. Okay, 12 times 6, length times width is 72 feet squared for that kitchen. Okay, now the bathroom here. Well, right from there to there, it's half of an inch. So from there to there, it's half of an inch. So in real life, half of 12 is 6 feet. Okay, from here to here, it's the same as this guy right here. So the bathroom and the kitchen are the same size. Because right there to there is 12 feet. See how this is matching? So 12 by 6. I'm not going to label right there. I'll just label at the end. So that's 72 feet squared. Or I could say square feet, okay? Closet number 2. There it is. So from here to here, it's 1/4 of an inch. So I got to go 1/4 of an inch times 12. And remember, multiplying by 1/4 is the same as dividing by 4. So I can go 1/4 times 12, or I can go 12 divided by 4. Times 12 is 3. So that closet is 3 feet that way. 3 feet by, well, that was 12 feet. So 3 by 12, or 12 by 3. And 12 by 3 gives you 36 feet squared. Okay, bedroom number 2. So from here to here, it's the same as all those guys, which is, that's 1 inch on here, so it's 12 feet right there. So it's 12 feet by 3/4 of an inch. 3/4 times 12. 3/4 is 0.75 times 12 is 9. This bedroom right here, from there to there is 9 feet. 9 by 12, or 12 by 9. 12 times 9. 108 feet squared. Let's toss it up a little bit. Let's go square feet. Same thing. Those are interchangeable. Okay, closet number 1. Oh, that's a weird looking closet. Okay, so from here to here is 1/4 of an inch. So that little guy right there, 1/4. I have to go 1/4, or 0.25 times 12. Okay, that's 3 feet in the real thing. 3 feet by, well, I don't know how long it is right here. How can we figure that out? So from there to there, is there anything we can do to figure that out? Oh, okay. So if this whole side right here is 30 feet, and this right here is 12, I need to go 30 minus 12 to get from here to here, which matches that closet, okay? $18. So that means from there to there is 18 feet. So therefore from there to there is also 18 feet. So it's 18 feet by 3 feet in real life. Okay, length times width is going to give me 54 square feet, or feet squared. Okay, bedroom number 1. There it is right there. So I see that right there, it's 12 feet. Now 3/4 of an inch, so I have to go 3/4 times 12. Gives me 9 feet, so that's 9 feet in real life. So it's 9 foot by 12 foot, or 12 foot by 9 foot. And 12 foot by 9 foot is 108. Okay, now the living room. See how that's kind of a weird shape? It's like an L shape right there. How would you figure that out? What could you do? So we know that, let's see. Let's look at living room and bedroom number. Okay, so I'm going to look at this right here. Let's highlight it. This is what I'm focusing on. Okay, and find the length times the width of that. So, let's see, 21, well, hold on. That whole side is 24, so 24 minus the 3 right there. From here to here is 21 feet in real life, okay? Okay, that whole green line is 21 feet. So 21 by 18. And that is right here. This is the living room, right? I mean the living room and the bedroom, number 1. Okay, 21 times 18 gives me 378 feet squared, okay? That's for this entire thing, but I don't want this right there. I just want the living room. So what was the area of bedroom number 1? Let's find it. Bedroom number 1. There it is, 108 feet. So we're going to take this number, subtract bedroom number 1, which is 108 feet squared. This is bedroom number 1. And that's going to give us just the area of the living room. 378 minus 108 is 270. And that's going to be feet squared. So the living room area is 270. Sorry about that. I'm glad you're listening to me and not just watching this. 270 feet squared. Okay? Alright, here's a giant hint. If you did not understand how to do number 8, so the one we just did, you need to replay that part of the video. And if you still have questions after you've replayed it and worked it out, you need to bring those questions to me, okay? Specific questions. You can't just say, I don't get it. Specifically, what part don't you understand, okay? I can help you better if you're more specific with what you don't understand, because I can't read your mind. All right, bye.